Welcome to the Internet of Things equation, a podcast when I talk about the Internet of Things domain both from the technical and business perspectives. I'm Łukasz Malinowski, the Internet of Things advisor and trainer. My today's guest is very special to me. Some time ago, I was preparing a research on leveraging IoT technology in agriculture. I reached out to Shawn seeking his advice. He agreed to meet with me and we talked for over an hour about various aspects of utilizing the Internet of Things technology in agriculture and possible technical solutions. When I started this podcast, it was obvious to me that I have to invite him on. Hello, Shawn. Thank you for joining me today.
All right. Thanks for having me. Appreciate the opportunity to talk today and to talk to your audience.
Yeah, so could you briefly introduce yourself to the audience so they know your background and what you're focusing on?
Sure. Yeah. So I'm a developer. I've been developing applications for the past 26 years now. Most of my focus has been on distributed systems development for well over 6 years now. I kind of began in the enterprise architecture space doing integration work as well as cloud technology work. So I'm one of the people who remember the old version of Azure. So I'm an Azure architect as well. And so I work in that space quite a bit. I'm also the owner of a small startup called Green Nanny, whose focus is on helping cultivators for like legal cannabis in the United States, but as well as controlled environment agriculture. A lot of that at the moment is, product development. But my background as a consultant has given me the opportunity to work with a number of different type of IoT projects. Probably my favorite is agriculture specifically, because I have my own garden in my backyard and my own aquaponics system. Probably the majority of experience I have is in manufacturing, because I think that's where kind of the most of the demand is. So my experience ranges from small handful of agriculture projects as well as working with very large food and beverage manufacturing organization, all the way to really specialized IoT work, which I've had the privilege of doing, which is like tracking very specific types of machines and grabbing the time series data off those, as well as helping teams actually develop embedded devices. So my experience is pretty broad. I am a certified IoT specialist through Azure, but I think of myself more as an IoT generalist. So you won't see me doing a lot of hands-on embedded development very often. Most of what I really kind of focus on is the data side of things. Like let's take the data, let's use that time series data, let's build insights from it. That's kind of my background and where I sort of fit in with the technology stack of IoT. Is I consider myself far more on the data side than the actual device itself side.
The agriculture, this is the space when we can use technology for good and not only to produce some new shiny toys, but also improve people's lives. And IoT has become a widely adopted technology in the agriculture space. And you have extensive experience in that area. Could you explain the main reasons behind that popularity of IoT specifically in the agriculture?
I would attribute a lot of it to the intelligence and the craftiness of farmers themselves. I know a lot of people don't think of farmers as being sort of pioneers in the technology space. But as far as IoT and agriculture and crop planning and plant monitoring, there has been a lot of technology put in this area. Now, it doesn't always necessarily translate equally across all of agriculture, but here in, I would say, Texas, IoT is often used for things like tracking cattle. Now, it's not necessarily plants, it's, ranching, but you use IoT to track cattle. You'll use it to basically, use drones as well as like soil samples as for planning out and determining like the condition and the state and the health of your soil. Food is a commodity product. So as those prices get lower and lower, farmers are kind of faced with, okay, how do I make the most out of the technology around me that's going to, save me on money and also help me kind of make some predictions about where things are going with either weather or soil or any one of the primary areas of plant health. That's, I think, probably one of the number one reasons why today, if you're, definitely if you're a commercial farm, one of the larger corporate commercial entities, they are using a lot of this IoT type technology, not only land-based, but also even space-based, like satellite imagery and things like that. But for the small farmer, like, myself, I've got my own, stuff in the backyard, but IoT equipment has become more affordable. There's consumer level IoT equipment if you're good with using that. That's rather cheap, and you could basically use your phone to track the data on it, help you recognize healthier plants, all of those things. So I think the span of the capabilities of IoT have really fit with where agriculture has moved. Personally, I think we're going to see more agriculture moving into like urban spaces, so smaller CEA style products and companies building out and producing food, especially since post-pandemic. I think we saw a lot of issues with like our supply chains, and so there'll probably be some changes around that. I think IoT is one of those tools that you can put in the hands of like someone who is a horticulturist or has some basic farming knowledge, and then get much greater results out of it.
You touched on something very important, and I remember that you actually provided way more details during our offline conversation like a few months ago, which is the economics of IoT in agriculture. And what you mentioned is that farmers can leverage IoT technology to gather data about plants, but also weather predictions and market economy to maximize the profits. And I think that is very novel view on the IoT as a technology that enables farmers to maximize profits of their work. So maybe could you dive a bit deeper for the audience in this concept and how actually this whole thing works altogether?
Sure. Yeah. So I'm not an economist. So I'll just I'll just preface with that. So let me pick on one particular segment. So let's talk about hemp or cannabis production specifically. So this is one of those crops, and one of the things that I think your audience may want to understand is that plants and agriculture and all of these things are a slow factory, and by that I mean you are sort of building the manufacturing process around the plants, right? The plants don't move through an assembly line or anything like that. They may move from like room to room, and they do have different stages that they develop at, but for the most part, it's a slow moving harvest. So the typical time for medicinal cannabis, it goes from either being a seedling or a clone through a vegetative stage, through a flowering stage, and then there's even a processing side of it. And that whole process can take up to 100 days. If you think about your investment that's involved in this process, you are putting a lot of time, 100 days worth of time, and money and effort into a crop. And so one of the primary things you want to do is make sure that crop isn't going to fail. That's where IoT really helps. There are, I would say, 14 different kind of points that you can monitor around plants, and most of them are commonly known. It's going to be water, light, temperature, humidity, the soil that it grows in, its root health, the biome around it. So there's a whole slab of things that are part of that plant factory that you want to monitor and cover. That's the best way to think about it. Is it's like a life support system for plants, right? So that's your first kind of insurance policy to make sure that, okay, I've planted this harvest. I'm gonna plan a harvest around this plant. I'm gonna monitor it to make sure it's meeting all of the particular conditions that will make it a viable product on the market. Whether that's tomatoes, carrots, beans, cannabis, it doesn't matter. They all have to fit within certain specifications to be edible or consumable in some way. If you are mature enough to be collecting all of this data about your plants, over time, you're going to be able to do much better crop harvesting. You'll be able to basically determine what's needed and what's created, which then brings to the, okay, now if you're doing this, can you align things with the economy? Can you align it with the market demand, right? And so that works really well in cannabis because I can track what strains am I growing that are selling well at individual dispensaries. But even from the larger agriculture side, I can see, hey, what's my commodity prices on corn or potatoes and look at trends around that and say, okay, maybe I can grow my harvest around those particular economic and marketing trends as well.
You touched on a very interesting topic, which is solution design, and we will cover that in a second. But I want to ask you one additional question about the farmers themselves. The Internet of Things technology attracts young people to work on farms because they can obtain IT skills this way. That creates very interesting dynamics, as people are building IoT solutions for a specific problem instead of just playing with technology, which was an issue at the early stage of adoption. And so, what's your perspective on that? Do you really see people interested in combining the farming part of it and technological part of it?
I think so. I've spoken with probably a few people who are getting into IoT, and a lot of their question is about practical application. To me, that is the purpose of IoT. IoT should be thought of just like a health device or something similar to that, right? So it's a very specific thing. And I think one of the pluses of where we're at right now is around the cost of IoT, right? The cost of IoT equipment, the cost of like the software around collecting it. You're no longer stuck having to buy sort of high price IoT devices. You can actually pull together a lot of open source things and even older computers, and you can use those computers as like edge devices and gateway. You can run, something like Node-RED and kind of manage the IoT side of it from a kind of drag and drop perspective, as well as devices themselves are, again, fairly cheap. You can get some pretty cheap moisture sensors and temperature sensors and all of those things. I think that there's a draw to people who just like to build stuff and make stuff that IoT has. But the plus side is all of that, where it's at now from the industry, where there's so many like Raspberry Pi type devices or smaller devices that I can get my hands on and work with. I now have the opportunity to build out more complete systems. Now, these may not be what you would consider like enterprise scale systems or something like that. But if you're managing a small remote farm, you can still buy older computers. You can load them with a version of Linux. You can load them with, an IoT gateway of some kind, like Mosquito or something like that. All of that's open source. And so for very little money, you can build a very operationally sound IoT system. Now, what does that mean for like young people who are kind of, wanting to get into technology? Well, it gives you an opportunity to learn something other than just JavaScript and web applications, which there's nothing wrong with that, right? I mean, those are excellent places to kind of start with your tech. But being able to get your hands on like actual devices and learning about the communication around the devices, I think that one of the things that IoT really teaches you, if you're getting in early in tech and you're working with IoT, is the concept around distributed systems, as well as communication, as well as networking, as well as working with an operating system like Linux and understanding how it works, as well as some of the more lower level communications. Like if you actually start working with Raspberry Pi, you may want to really pick up that stream off of that particular moisture sensor, and so knowing how to address those particular channels. So I think it's more than just building an application, putting it up on the web. Again, nothing wrong with that, but you're now learning all of these kind of other computing elements that you may not have been taught in school or even college, because a lot of times the focus there is on the basics and the fundamentals of understanding data structures and programming and that. Here you actually get your hands on distributed systems and learn how distributed systems work well together, which sets you up for the majority of where everything is at. We have a lot of cloud technology, even on premises, you're going to be working on distributed systems. So that's one of the big pluses, I think, for young folks who are really kind of, new to the industry and want to get in technology. That's a good place. And of course, combining it with farming allows you to take that, right, that kind of technology and see practical applications and understand how it's helping to basically create food and other products that are derived from farming.
Myself, I started as PHP developer many years ago. I was always attracted to all IoT concepts because for me, IoT is the physical manifestation of a software program. Because you write software that can actually impact your surroundings, which is pretty profound. So I totally agree with you that starting with purely IT skills, basic programming, basic data concepts, That's very, very handy. And then you can go a bit further on your journey to learn about the physical part of it. Which brings me to my next question, because you are a principal solution architect and you mentioned that briefly, but I would like to go into way more details with you. What is the difference between designing typical IT system versus designing solution for agriculture? Because you mentioned that this is like the slow production line with 100 days of process and so on, but maybe you could give me a bit more differences and details, what you need to consider differently when we speak about the agriculture versus typical IT type of deployment.
Absolutely. So I think that the first thing always, as any kind of development effort, even if it's an IoT development effort, is to understand your customer and your user and what they need and what they're trying to achieve. The first thing you want to do is really start with the conversation around where your various pain points. What would you like to have more insight into? What is it that you're not seeing today that you would like to be able to see? As well as having a pretty firm understanding about the particular type of plant that you're going to be building, or plant or animal, or whatever the use case is there from an agricultural perspective that you're going to be monitoring. And so this kind of translates over to any kind of technology that you're working with. From a business perspective, you always are going to want to address, like with your users, what are the things to consider, and what's the problem. Now, you as I would say, a solutions architect who's working with IoT, you really have to kind of go in and understand your environment, right? So this is in physical environment. This is a little bit different than when you're just writing like a web application or something like that. In that case, you kind of need to understand your user, but your environment, you're building for the web. So there's already kind of a number of things that are decided around that. But if I'm setting up IoT for indoor agriculture, it's going to be probably a bit different than what I'm setting up for like my outdoor agriculture. I may need to consider things like very long distances between devices so that they can speak to each other. So that may limit or make my decision around the type of protocol I use, how the devices communicate back to their gateways and hubs. So that may be LoRaWAN or something like that. I may also have to do something that's inside a building where that kind of radio transmissions do not work very well. And so I may have to look at something that's like a wired solution. And you'll see a lot of those in controlled environment agriculture. They tend to be managed by a centralized control system. And then you have basically wired devices that are tracking humidity and temperature and even moisture sensors that are wired. So I think that's another thing you have to consider is your physical space. Like, where are these devices going to be? Can they withstand the temperature? Can they withstand the humidity? Can they get watered on and still survive? So there's a lot of those kind of questions that you have to ask. And then, of course, you have to take all this into account with budget. Right. So how much money do you have to spend? What is the projected sort of return on investment for your farmer that you're working with? And a lot of that's determined by communications. There are certain things that we look at from the cannabis industry as KPI, or sort of performance indicators, and they revolve around things that are kind of hard to quantify sometimes. So you're looking at like quantity. That's pretty easy to quantify. We know when we've grown more each harvest. Quality, however, now on the cannabis side, we're really dependent upon testing. So testing that's sent off to the state to get testing on it will come back and it will kind of give you an idea of what the quality of your product is. But the other things are a little more difficult, like efficiency, right? So efficiency is one, and that really gets away from the technology and a lot to like the process. What processes are you following on your operations for plants? And so you would have, quality, efficiency, quantity, and then your final one is kind of like consistency. Now, consistency is important if you're growing anything really. If you grow tomatoes, you really kind of want to grow, and you're growing a particular strain of tomatoes, you want them to taste the same every time you grow them. Maybe improve, but you want a consistent product that you're creating. That's more important, I think, on the cannabis side than anything, because there's very recognized effects from particular strains. And so if you're not consistently growing that plant the same way, patients will know the difference. Like when they go and consume it, they're like, oh yeah, this didn't work the way it did last time, and that's not a good thing. There are KPIs that you can put around it that kind of give you an idea of what your ROI is, but I also think that needs to be a conversation that's had like with the farmer specifically.
From my perspective, it looks like a huge challenge is that long feedback loop because
Right.
in typical industrial IoT, the feedback is almost instant, and that's the whole premise of IoT. Like it gives you very quick verification of the parts that you are manufacturing, so you can adjust controls not to mess up future parts. But in your case, what you described is that you've got the field grown the same way, and you will get feedback at very distant future, or at least distant from the typical IoT perspective, I would say, which for sure adds extra complexity to the project because you need to try to foresee and predict things before you get that actual feedback. And since you are the data person, is there a way to predict and to include some advanced analytics in order to improve quality of your crops before you get the actual feedback and confirmation that that quality improved or not?
Yeah, definitely. So one of the first things that I would typically do with a farmer or somebody in the agriculture space is basically kind of key in or set our scientific instruments, our monitoring instruments with particular levels. Right? There's things that we hope that the farmer already kind of knows, like this is too much water, right? Or this is too much humidity. In books, like already some of these things have already kind of been established, right? And so you want to instrument your systems so that they reflect what you're expecting from the environment, and you want to know when things kind of move outside of those environmental settings that you put in place. So you want to know if, like, hey, we're overwatering our plants. Overwatering plants can cause just as many problems as underwatering plants. So you want to first thing you want to do is instrument your systems to kind of fit with this. Now that's already going to help a lot because you could put alerts and systems around when things go outside of these boundaries. That helps protect you during the harvest. If you're looking for, okay, how do we kind of make things like predictions about the weather and predictions about soil, that requires some amount of history. Now weather is pretty nice, you can actually get some public weather records. And if you want to start building sort of rudimentary forecasting models, there is a lot of crop data that exists. Now, the problem with that is it's going to be pretty generalized and it may not fit your particular area where you're growing. Growing corn in Iowa is much different than growing corn in Texas. And you can grow corn here in Texas, but they're very different environments. And so you have to kind of take that into account when you're doing any kind of predictive analytics work. I generally, like from the automation standpoint, I like to kind of approach it in the first phase, which is your staff is going to continue to take manual readings of things, as well as we're going to actually capture it from the IoT side. We're going to do comparisons between those two things to see, okay, is our IoT system doing as good a job as your staff are doing? And if that's the case, then we have that keyed in and ready to go. And it will need adjustments. Everything always does. So you have to kind of continue to watch that. Instead of the staff basically watching the plants, they're now kind of watching the IoT systems and the plants with a little less, effort continuously. Where things can get into automation, that's where we start looking at like, well, what's your watering schedule look like? Okay, let's try and do the same concept, right? Where still a human is going to come along and watch the automated watering system, make sure it's working correctly, do moisture checks, all of those things, until you get to a level of comfort that, okay, this system's there. Still has to be monitored, still has to be kind of watched, but you're automating more and more of your process as you go. During this process, of course, you're collecting data on all these things. And then once you start having that data, that's when you can start looking for trends and doing analysis on that and saying, okay, are there predictive models that we can create, like say maybe based upon growing a particular type of strain in a particular medium, in a particular environment settings. And that's where that kind of goes. And you may be aware of this from the industrial manufacturing side. Really, you want to get that model eventually kind of as close to like on the manufacturing floor, we'd want to get that, predictive model as close to the machine as possible, so that it's using like the vibrations off the machine to determine that, okay, things are looking bad. We now need to like do some work on this machine, and the model just knows it. Like the model at the machine level can then talk to the operator and say, hey, we basically need to do some maintenance on this machine because we're seeing issues. It's a little different on the plant side. There is work being done. There is in fact a organization, a company that has built a camera that can sit in the corner of like a grow room in a cannabis facility and can tell you if there's pest issues or problems like that. And it's all basically doing that with object recognition. So that's a good kind of example of like a model on the edge that can help you do some predictive work. So there are some things out there that are in play, like cameras that can basically look at fruit and know that, hey, okay, this fruit's ripe, it's ready for picking, instead of like a human having to go out and like look at it. Now, there's expense obviously involved in these things, but if it saves your staff time and saves you time and also catches things that the human eye might miss, that's a huge plus.
So let me reiterate on a few things you mentioned, because in my opinion they are extremely important and I want audience to catch that. First of all, the whole idea of IoT is to codify the domain knowledge that humans got, as you said, right? So farmers
Right.
know if the humidity is right or not, temperature and so on. And we need to codify that knowledge, sometimes which is very actually hard to codify in some cases, into some kind of software. Then what we do, and this is another excellent piece of advice that you shared, is that it's not that we are going to move all of that people out of the facility because we've got a system in place, right? We need to cross-validate if our brand new shiny sensors are giving any actual readings or just random data, which more often than not, from my experience, at the very first iteration, you get more or less random data, right? It doesn't give you any actual value, and that's what you mentioned, that you still got the manual labor that's cross-validating readings, comparing with sensors. Then we can fine-tune, and after a few iterations, we will get close enough, which allows us to do that 24/7 automated monitoring with very infrequent checks from humans. And going further, with what you described, is starting with something extremely simple and then growing on top of working solution.
Yeah.
If we start with too complex scenario from the very beginning, then it will be extremely hard, right, to manage the complexity that we created ourselves, and we will actually introduce more issues than we are solving. I think that you described excellent way of planning the deployment, few steps ahead, and the way to introduce that.
That's why I always kind of use the example of, especially in a controlled environment agriculture, that these are plant monitoring systems, meaning like they're monitoring the health of the plant. Now, if you think about a hospital and you're a patient in a hospital, you probably have all kinds of monitoring equipment around you, right? There's things that are checking your blood pressure and your heart rate and all these things. But having those things in place does not replace a nurse or a doctor. The hospital still has an entire staff of nurse and doctors and other people to kind of help the patients. These tools are just there to kind of help with the monitoring side of things, so that, hey, something does go wrong, nurses and doctors are alerted quickly and they can go take action and do what they need to do. I think the same thing is the case whenever I think of IoT. I like to kind of put it in that perspective with people who are making this investment, so that they understand that we're not going to be replacing your doctors and nurses that you have on staff. We're just going to free them up to be able to do other things other than monitoring all the plant side of things. I think that that's an important aspect whenever we talk about automation. Very rarely does automation just completely and totally replace a human. Usually it just supplements what they're capable of doing and makes their job a little bit easier, so that they can take on things that may be more important, that do require hands-on human capabilities, that machines aren't quite capable of handling.
Humans are extremely versatile, right? So doing the same readings over and over again did not really utilize potential of farmers,
Right.
and which is a great point that you bring, that it's not that we want to fire those farmers, we want to support them, and we want to enable them actually to improve and to leverage their skills and their intuition, right? Because sometimes it's just about intuition of the operator or the farmer in this case, to improve the outcomes. And technology is just to support them with those really basic stuff, right? Like reading moisture parameters is just the basic stuff. That's no magic into that. Like what is important is to understand the implications of specific readings that we get.
Yeah,
So
exactly.
you mentioned indoor grow facilities. Let me dive a bit deeper into that, because there feels like those are very controlled environments because you've got everything in-house, you can control it. Could you give me some more details of how does they differ from typical outdoor farms? And are there any challenges in indoor farming that we do not observe in classical outdoor facilities, for instance?
It's quite interesting. I would think the number one thing to bring up the fact that controlled indoor agriculture is more expensive than outdoor farming. You're basically paying for an environment to keep it cool or hot, depending upon where you're at, as well as you're paying for lighting the majority of the time. And so you've got lights that are now most lights have moved to sort of LED lights, which are cheaper. But when you're trying to flood an entire room with LED lights, they're still expensive. The lights themselves are expensive, as well as the amount of electricity they use. You've also got to come up with water. Now, there are some unique solutions around that. There's plenty of people who are pulling water off of here in the south of the United States. A common method is to basically take the condensation off your air conditioning, put it into a large barrel, and filter it, and then basically use that as means of basically watering your plants. So there are some ways of kind of reusing and saving from that perspective, but you have to be able to recreate those things. And what you're trying to do inside an indoor controlled environment is recreate the conditions that your plant would thrive under in nature, right? So if I'm growing strawberries, I want to have like a specific temperature, specific grow medium, light, all of those things to try and recreate what would happen in nature. Now, what is the advantage of growing indoor? It does allow me to have better control over all those environmental factors. And when you're doing things like growing cannabis or some things that are very specific and have a particular consumer profile you're trying to create, there's advantages around that. Now, with anything, there's also some disadvantages. You really have to take control over the pest and fungus and some of the other things that can kind of develop in that type of environment, because you're going inside and you're trying to maintain a high level of humidity for a lot of plants. And of course, along that can come with the plant diseases, pests that basically will get into the environment and cause problems, and just the expense that's involved. Now, the pluses, of course, of growing outdoor, or there's the sort of in between, right? So there's indoor, which is almost completely hermetically sealed type environments that are managed and controlled with a great deal of control. And then there's greenhouses, which are kind of your in between. You can control your environment a little bit better. You don't have to have as much money put into unnatural lighting. You can use more of like sunlight and the natural outdoor lighting, but you have less control over things like temperature and things that can get in, like pathogens or pests or those situations. Whereas a field, there's going to be less control. So I can kind of talk from a cannabis perspective. A lot of what you'll see is people who are growing very particular strains that grow best under certain conditions. So there are some strains that basically you can grow outdoors in a field and they'll produce fairly well. There's still kind of arguments about, well, is it as good as what you're growing indoor or not? And so there's kind of fighting back and forth on that sometimes. But just looking at it from a horticulturist perspective, there are particular plants that grow really well outdoors in a field and are still, and that is a huge economic benefit. You're really just taking advantage of like rainwater and sunlight and the natural environment, soil, everything else. So your expenses are down a little lower there, but you may not have as good a quality product Again, there's a lot of debate around that, so I'm not going to get too much into it, but a lot of people think, okay, that's not as good a quality of product as something that's grown in this indoor facility. What I've seen in the cannabis world is like more people are moving towards glass houses because of the great expense of trying to grow indoor and everything that's around that, as well as market acceptance of understanding that certain plant profiles are still just as good, despite the fact that they were grown inside a greenhouse. So some of it is that I'm going to grow on this indoor grow if I really want to be able to grow a very specific thing, and it has very specific environmental conditions that I need to create that may not even be natural to like my environment that I live in. I'm going to do that on an indoor grow. For the majority of the plants that are kind of hardy, that can survive on their own, I'm going to want to grow those in the field just because of the less expense, right?
It looks like there is the universal truth. The more control you want to have, the more responsibility you take. And this is
Yes.
the same for IT systems. And what you said is exactly the same for agriculture and for the nature. That if you want to control nature at every single bit of the process, then you need to make your best to provide inputs required for the plant to grow. Because otherwise you will just mess it up and the output will be not as good as you would like to have.
Yeah, exactly. And some of the times the danger of growing indoors is if you haven't separated out your harvest into different rooms, you may have everything in like one big room. If a pathogen or a pest or something like that starts attacking that room, you could lose your whole crop that's in that one room. That's often a problem that we look at from the aquaponics as a different thing that I kind of work with. But, we've got to be careful that, what we do doesn't kill all the plants and the fish, right? in one go. And because it's a looped cycle, it's like a closed loop cycle where, the water is going from the fish to the plants, from the plants back into the fish water. And it kind of works in that loop. Well, if something dangerous or poisonous were to get into that loop, well, I've lost my fish and I've lost my plants and I've lost that whole kind of crop. That's an important consideration also when you're working in the indoors. There's a lot more vigilance that has to take place when you're doing that.
You mentioned one thing during this conversation that is very important, mostly from the educational perspective, which is the edge computing. And you said that you can use some old PC, install Linux on it, and use open source tools to create the edge gateway or edge logic, which allows you to learn so much. I can tell from my experience. It allows you to learn most skills that you need at any IT job in the future if you decide to go purely for the software role or IT admin role, for instance. But maybe could you elaborate a bit more on that? Because as a principal solution architect, you know that IoT is moving to the edge for various reasons, like the cost, the privacy, and so on, right? What about agriculture? Can we create IoT solution mostly leveraging the edge infrastructure, those old PCs, for instance, without investing in the cloud backend? Is it possible to build everything on-prem, or some kind of cloud backend is still required?
I think I would still use some kind of a cloud backend, but I may use it specifically for just holding my time series data. For instance, if the kind of I would say that the dirt cheap IoT solution is a Raspberry Pi basically running Node-RED as your edge side of it, with enough memory to be able to kind of collect something and store it locally. And then I could use something like Azure's IoT Edge. Now it's a little out of date at this moment. There's more work kind of being done to use a lighter version of Kubernetes to replace it, like K3S or however you want to pronounce it, one of those type of solutions. But I would use that and then have some kind of a cloud storage where I'm taking that data and dropping it up there on some kind of a batch type process, right? So depending upon the amount of data I'm gathering, I may drop it every 15 minutes or something. And then I've got my data lake. I can then use that to do any of my local processing if I want. So the way I could see this possibly working is I could have old PC that's basically running Linux. I get some type of a container system up and running, whether it's Kubernetes or just Docker or something similar to that, which is then running my edge workloads. I'm storing it locally, maybe on an SD card even, or something like that, where I'm collecting my time series data that's coming in, and then I'm taking that data and I'm going to drop it up to the cloud maybe every day or hour or whatever the increment needs to be. Now, the challenge around building that kind of system gets into like device connectivity. How do devices connect to this PC? What's the process for that? And that's where you start looking at, maybe needing to connect a router of some kind that the devices can talk to. But it sometimes also gets down to like, well, what is the device that you're using and what does that look like? So a lot of the decisions around how am I going to collect my moisture data and what am I going to do with it and all those things. Luckily, in my position, I can basically send all that data to my Raspberry Pi over Wi-Fi, which is great for like my backyard hookup. But if you're trying to use LoRaWAN or one of those type of solutions, you're going to need to have a specialized card for basically capturing those LoRaWAN signals that are coming in. It's not quite as easy as like I can just go buy some parts off the shelf and go home and create a full IoT system for my farm, but there's enough of the cheaper parts that you can. A lot of it just gets down to that, again, some of those first things we talked about, the considerations whenever you're looking at architecture. Are you building this for like a small greenhouse? You might be fine getting away with just Wi-Fi, right? And using that as your kind of primary communication protocol. But if I'm at a big field, then I may want to look at using, LoRa or building a LoRaWAN. And if that's the case, I may want some more specialized equipment. It doesn't mean that I can't bring like my own edge devices into the mix. You may also find that the gateway you buy now, just out of the box is an edge device. I've noticed that recently, like a lot of the gateways just automatically, if you buy a gateway, it actually comes with, a small OS where you can load a container and you can run, edge jobs on these gateways. It's really gets down to like what you're wanting to do. Hate to sound like a consultant, but it depends, right? It depends upon what you want to do. But I can tell you for under $500 or $600 US, you can get a Raspberry Pi and almost everything you need for all of your plant monitoring together, load all your software on it, and you can just use the Raspberry Pi. I often remote into my Raspberry Pi that's sitting inside my greenhouse and just do stuff from the Pi and check on it. And then from the Pi, I can connect to Azure, and that's where I basically send my data. And so it will connect up to Azure. It'll drop the data into a storage file on Azure Storage, and then disconnect, and that's what I've done for the day.
Let me reiterate once again for the audience, because I believe that is great advice, or at least the advice that I give my customers, so probably that's why I find it so great, is that cloud is basically infinite storage and compute capability. And as you pointed out, you've got your logic at the edge, you got the data, you probably create some batches to reduce the telemetry upload costs, both for the connectivity and cloud infrastructure. And what we can leverage cloud for is to keep track of the historical data and run some huge scale processing and analytics on top of the data. Because that is basically the most value that we get out of the cloud with pretty limited investment of time and money. And of course, if you want to get fancy, you can leverage other cloud services, both from the cloud perspective and from the edge perspective, to fine-tune your solution. But for people starting, even if you are a business thinking about starting the IoT journey, keep it simple. Keep it simple, as Shawn said, start with simple edge deployment, start with very simple setup on the cloud side, and learn characteristics about IoT itself. And in the process, you will learn so much about your own field, because you will gather data that normally you cannot gather by hand. That's great advice, and I'm totally supporting that approach in a way that you structure the whole roadmap of introducing the IoT capabilities to your specific field. What's the best way for people to reach out to you, to contact you if they want to learn from you, if they want to cooperate with you, how they can basically get in touch?
I would say go to LinkedIn. I'm on LinkedIn. I think I am the only Shawn Deggans on LinkedIn. I may be the only Shawn Deggans in existence, but I haven't proved that yet. But yeah, so I would say reach out on LinkedIn, connect with me on there, and message me. That's probably the best way at this moment.
For the record, that's the way I actually approached you and had the chance to meet with you and leverage your knowledge in the field that I was working on. Shawn, once again, thank you so much for taking the time to meet with me today to share your experience with wider audience, because I find it extremely important for hands-on professionals like yourself to sharing that knowledge. Because when I started, and for sure when you started as well, that knowledge was not available, and we had to learn everything in the mostly wrong way, the very hard way. Right now, it's our time to give back to the community, right? So I really appreciate your time and your insights. I believe that they helped a lot number of people considering to start in IoT in general and utilizing IoT in agriculture in more specific.
Absolutely. Well, I really appreciate coming for you bringing me on and getting the opportunity to talk to your audience and discuss this with you. It's always great having a discussion with you on this stuff. It's fun.
Thank you for listening. Go to thefingers.com to find more materials about the Internet of Things domain. My name is Łukasz Malinowski, the Internet of Things advisor and trainer.